So dilutions, what you're trying to do is you're changing the concentration, okay? And so there's a little bit of a calculation involved. And so there's a little formula. It's really not that hard. We'll kind of go through and look at the formula and sort of how you can rearrange it. Um, because kind of like this example that's given right here, it says in a hospital emergency room, there's a patient suffering from hypokalemia, which means that they have low potassium levels in their blood. And so in order to adjust that or to kind of counteract it, they might put an IV in the person and they might give them fluids through the IV, which IV stands for intravenous. That means it's going in to the vein, so directly into your bloodstream, which is the fastest way that you can deliver medication to somebody. There are other ways, like in my IB class in medicinal chemistry, we talk about there's subcutaneous, which is like under the skin. There's intramuscular, where they do it into your muscles. That's typically how we get like shots and vaccines. You know, they put it into your arm or into like your hip when it goes into the muscle. But intravenous is the fastest way. It goes directly straight into your vein, into your bloodstream. And so it starts affecting you like pretty quickly. So a physician or a doctor, they might order an IV and they would say, okay, it needs to be 100 milliliters. More than likely, they wouldn't say milliliters. They would say 100 cc's, which is the same thing as a milliliter. CC stands for cubic centimeter, which a cubic centimeter and a milliliter are the same size. So when you watch medical shows, they're like 100 cc's of whatever stat. Milliliters and cc's or cubic centimeters are the same thing. So they would say like 100 milliliters of, or 100 cc's of a 0.5% solution of potassium chloride, because that compound is going to increase the potassium levels in the patient's bloodstream. And that would hopefully counteract whatever symptoms they're having. So an aide or a nurse that's going to be administering that, they don't like go to the supply closet. There's not like an IV bag that's going to be exactly 0.5% KCl. Sometimes what they have to do is they actually have to make the solution. They have to dilute it. So they have what's called a stock solution. A stock solution is like, you know, maybe it's not 0.5%, maybe it's, you know, a 10% solution, or they might give them a molarity. It might be like a 2 molar solution or a 1 molar solution where they're giving them the concentration. And what will happen is the nurse or the aide will have to dilute the sample by doing a calculation, figuring out how much they need to use, and then determining the amount of water that they need to add to it. Okay. And so if this calculation is something that it's used in, you know, real life situations like this, because if you do the calculation wrong and you don't put the right amount of water, you could give them the wrong dosage and it could be fatal, because, you know, doctors and nurses, you're making life altering decisions sometimes. So, and then there's just a little visual here of the IV. And so basically they would have in the syringe, they would have the IV bag, and then they would connect it to the person's IV line in order to give them the solution of whatever fluids they would need. So there we go. There is a little video here that I would encourage you to watch. I'm not going to play it now because we know that it lags sometimes when we're here on Zoom. But basically, it's going to go through the important information, the vocabulary, examples of dilutions. It's going to talk about the formula. And then basically you have a few drag and drops down here. Basically, it's just to check to see if you watch the video. Okay, it's really not that hard. But I'm going to move on and I want to look at what happens when you dilute something. Okay, so a dilution means that you're making a less concentrated solution from a more concentrated solution by adding more of the solvent. And as we've talked about previously, for all of our solutions, they're typically aqueous solutions. So like 99% of the time, our solvent is always water. So this is just like if you were at home and you were trying to make, like, let's say you were trying to make lemonade or Kool-Aid or something, and you know, you follow the directions in the packet, but then you're like, wow, it's way too sweet or way too sour, like it's too concentrated, too strong for your taste buds. So you could add some water, that's more of the solvent, and what you're doing is you're diluting it. You're adding more of the solvent particles and it's going to make it less concentrated, which means that that is going to kind of dull those tastes and it's going to make it taste less sweet or less sour. Okay. You could make it more concentrated by adding more of the solute if you wanted to add more like of the Kool-Aid powder or the lemonade powder. But to dilute it, you're typically going to be adding more of the solvent, which is usually water. So these two images, the one on the left here, this one is the more concentrated solution. You can tell if it's a solution that has color, it's easy to tell because the darker the color, the more concentrated it is. If it's not something that has a color, like there's a lot of solutions that they're just clear. So, color is a good indicator of if it's concentrated or dilute, but that doesn't always work because not all solutions have a color, okay? So what you want to look at is, or what you want to think about is the ratio of like solute particles to solvent particles. If I look at this one, if I zoom in and I look at all the different particles that are dissolved or they're floating around in the solution, I can see that it's pretty even. There's a lot of solute and about the same amount of solvent. But if I look over here and at this one that is dilute, if I look at the image of the particles that's zoomed in, there's a lot more solvent, a lot less solute if you kind of compare the ratio of these two images. And so what you've done is we've added water to this. And by adding water, you can see the volume increase because over here it was, under 100 milliliters. Now it's over 300. So we added a bunch of water or our solvent. And so now there are a lot more solvent particles for every solute particle, and that makes it dilute or less concentrated. Okay. There is an equation to calculate this. All right. It's the dilution equation. It's M1V1 equals M2V2. Sometimes instead of M's, because the M is representing molarity, which you guys learned about last week, which is one of the measurements for concentration. Sometimes instead of M, they will have capital C's here because the C stands for concentration. So like I know in my IB class, the way that the IB curriculum is set up, they have C1V1 equals C2V2, but it's the same exact equation. It's just in this one, the M is meaning molarity, which is concentration. If you see a C, that's just standing directly for concentration. But you have the molarity or the concentration of your solutions, and then the V's are your volumes. Now the difference between the ones and the twos, the ones are your initial solution. So that would be like your stock solution that you're starting with. So typically for stock solutions, you're going to know the molarity or the concentration because it will be printed on the bottle somewhere. Okay. And then you'll know the volume because you will measure out the volume. Okay. For the twos, those are going to be the final solution. So this is going to be your diluted solution. So typically when you're doing a dilution, because if we look at the pictures here, the volume increased in these two beakers. So typically what happens, your V1, if that's your stock solution, your V1 is usually a lower number than V2, because V2, your final volume, it's usually going to be more because you're adding water, you're adding a solvent to the solution to dilute it. Okay. And then M2 is the molarity of that final solution because for example, in with the IV example, if they know the molarity of the stock solution and they know they want to make 5.5%, like if that's the concentration of their final solution, and they know, oh, I need to make 200 milliliters of it or whatever it was that the doctor ordered, they would need to solve for V1. They would need to solve for how much volume of that stock solution or that initial solution would they need to measure out and then add water to in order to end up with the final volume here on V2. One sort of, I don't know, like specific thing here for the volumes, they could be in liters or milliliters as long as they are the same. So if V1 is milliliters, V2 has to be milliliters. If V1 is liters, V2 has to be liters. If you were talking about like that medical example, like I mentioned, they sometimes measure in cc's or cubic centimeters. So if one volume is cubic centimeters, the other one has to be cubic centimeters. They just have to match, because if I have one in liters and one in milliliters, that would be like me trying to compare like feet to yards, and that doesn't work. Okay. So here, this is just checking to kind of make sure that you kind of understand what we talked about up here with using this equation. Okay. And it's also from that video on the previous page too. Okay, so here is the dilution formula. This is pretty straightforward. I'm not going to drag and drop it because I know you guys can read on that previous page to kind of set up the equation. What I want to look at is how do we rearrange it, okay? Because you're never, and I'm going to go back to the previous page really quick. So this is how the equation is set up, but you're never going to actually use it exactly like how it's written right here, because you're always going to be solving for one of these variables. You might be solving for M1, you might be solving for V1, or you might be solving for M2 or V2. So you're always going to have to rearrange this in order to isolate one of those variables. And what that means is you want to get everything else to the other side of the equation, the other side of the equal sign, and you only want the one that you're trying to solve for by itself on the one side. So that's called isolating the variable, if you guys have not heard that a lot in your math classes. So this one says they want us to rearrange the formula so that we are solving for M1, okay? So if I go back to this previous page, how do you guys think that I would get M1 by itself on one side of this equation? What would I need to move or rearrange to do that? You can type in the chat, or if anybody wants to unmute and they think they know it. So what are we doing here? We're multiplying here. So what's the opposite of multiplication? Division. Somebody here said division. So if I want M1 by itself, what am I going to have to do to V1? Yeah, I'm going to have to divide V1. And just like in math, like whatever you do to one side of the equation, you do to the other. So both sides are going to get divided by V1. So V1 is going to move and it's going to come over and it's going to be down in the denominator on this other side. So how that works on this next part is I know I'm solving for M1. So I'm going to put M1 over here. And then I know the other side is going to be M2 times V2, but we had V1, like V1 was over here, but we just said that we needed to divide by V1. So that means it's going to be gone from that side because it's going to cancel out. And then we have to divide this side by V1 as well. So if I rearrange it to solve for M1, this is what it would look like. I would need to do M2 times V2 and then divide by V1. And when I did that, that answer is going to give me that initial molarity or that initial concentration. So I can check and it's correct. So the other ones that are on here, they're asking you to rearrange it to solve for all of the other ones. So you're going to have three more. Like this one, you're solving for V1, this one's V2, and then the M2. Okay. So just make sure you look at your initial equation and think of which one are you trying to isolate or get by itself. And then you're going to have to divide one to the other side and set it up that way. Because these four where you're practicing rearranging, this is actually how you're going to use the equation. You're going to use one of these four that you're going to kind of put together here. And that's what you're going to do on the next page, because these are the, oh, I clicked on the wrong arrow. The last part is actually practice problems where you're going to be given numbers, you're going to be given concentrations and volumes. And your job is to figure out how to arrange the equation and then plug the numbers in and solve for it. So for example, this one says practice problem number 1, solving for initial molarity or M1. For Alex to complete a lab experiment, he needs to make 1.50 liters of a 0.25 molar NaCl solution. What molarity of would the NaCl need to be if he has 0.7 liters of the solution? Okay. So basically you want to go through and identify your initial values. So M1 and V1, okay. It says the starting, so this keyword here, he has 0.7 liters. So that's what he's starting with. So that would be his initial volume or V1. M1 is the question mark because it says what molarity would he need if he has that much volume to start with. Then for the final values, final is what he needs to make. So typically if you're trying to make a solution, that means you're trying to dilute and make that solution. So M2 and V2 are going to be from this first sentence. The 1.50 liters is V2 because liters is for volume. 0.25 molar, that's molarity or concentration. So that would be our M2. So then here's my equation. I need to set it up to solve for M1. And so I would rearrange it to where M1 is by itself on one side. And then I would type it in the calculator. Okay. So here it's going to have you type in what are the values that you identify. Okay. If for the missing one or the unknown, just type a question mark. Okay. Then you'll rearrange the equation. So I'm solving for M1, and then I need to make sure I put my numbers in the correct spots over here based on how the equation needs to be rearranged. So I'm solving for M1, and up in here in my directions, let's see where we go at. Here it is. So my M2 was 0.25, my V2 was 1.5. So I'm going to plug those in. Here's M2 times V2. And then I'm going to divide by V1 because I had to move it to the other side. I had to divide both sides by V1. So I'm going to set it up like that. And if I check, they're all in the right spots. So then you can put it in your calculator, and then it says, make sure you round your answer to 2 decimal places. So make sure you read, some of them are 2 decimal places. I think there's one that has you rounded just 1 decimal place. So make sure you rounded the correct decimal places and you can check your answer. So then here's another one, but notice there's not as many directions on this one. The first one, I gave you more guidance since that was the first one. The rest of them, you're going to be in charge of like identifying the values, setting up the equation, and then calculating it and typing in the final answer. Okay. So there's another one there. And then there are 2 more on this page. Okay. And then when you're done with everything, you've watched the videos, you've done all the activities, you've done the practice calculations, all that stuff. Make sure you go to this last page and make sure that you check that everything's done, and then make sure that you submit your report for your grade for today. All right.